Hello, this is Miss Cliffner with your video lesson for today. We are working on 5.7b, so this is the second lesson on converting any kind of measurement. You can, and I know the essential question says, how can you compare lengths between customary and metric, but sometimes we convert within customary or within metric, and you still need a conversion factor. So you're writing down the homework in the planner. It's 5.7b. It's a worksheet, even though the problems are coming from the textbook. I want to see your work for these for this section. Okay, and of course it's due on Monday. Okay, so here's the warm-up. I'm asking you to practice converting on A, B, and C, and then D is just a general kind of question that says, when do we use the equal sign, and when do we use this, which means approximate sign? When do we use those for making conversions? Okay, so I'm going to do A with you, and then you should pause the video and try B, C, and D on your own. All right, so for A, I'm looking at a conversion factor, and what I always do is I look at the units that I'm working with. I'm working with pints and cups. So what I want to do is I want to think about this gallon guy. I'm going to make this a little bit bigger. And I need to know the cups to pint conversion. So I know it's a little blurry, but what I want you to see is that inside each one of these pints, you see the two C's, there's 2 cups. So that means for every 1 pint, it's equal to 2 cups. Okay, so I'm going to shrink this and move it back down in the corner, off to the side. Oops, there I am. Okay, so here's the deal. The conversion factor is always a fraction, right? So it's 2 cups for every 1 pint, or 1 pint for every 2 cups. And it's the same number, right? I just flip the fraction upside down depending on what I need. And then I look at my answer. My answer has to be in cups. That means I want the cups to be on top, and I want the pints to go away, which is I want the pints in the denominator to cancel out. So I write it like this. 3 pint, and I put it over 1. And if I multiply by 2 cups for every 1 pint, then the pints in the numerator and denominator are going to cancel out. So then remember, when I multiply across, I get 3 times 2 is 6. And then the units are cups. And then on the bottom, the units canceled out, and it's just 1 times 1, which of course is just 1, so I don't even need to put 1 on the denominator. The answer is 3 pints is equal to 6 cups. Okay, so try the other ones on your own. I'm just going to go ahead and put the U.S. customary to metric up here, because you're going to notice that you're changing inches to centimeters. So this is the units that you're going to want to look at. And then when it comes to C, you're doing meters to feet, which is metric to customary. So here is your meters to feet. Okay, I'm going to go ahead and erase that and erase that, and I'm going to put this back down. Okay, so here we go. Right, so my conversion factor for B is inches to centimeters. So I've got 1 inch per 2.54 centimeters. There's my number 1. Or I flip it around and I do 2.54 centimeters for every 1 inch. And now I'm going to write the numbers that I have in my problem. 75.2 inches. I want to use the conversion factor with inches on the bottom and centimeters on the top, because I want my answer to be in centimeters. So I put this over 1 and I multiply by 2.54 centimeters for every 1 inch. And then the inches in the numerator and denominator cancel out. When I multiply across, my answer is already in centimeters. And I need to do 75.2 times 5.4. and I get 191.008 centimeters. And that's my answer. Don't round, right? Don't be afraid to put a decimal. I mean, anything past 4 decimals, I don't recommend, but it's okay to have up to 4 decimals. Okay, so I already gave you the conversion factor for this, so I'm going to show you the one that I'm checking. I mean, I didn't tell you the order, but it makes sense for C to use this as my conversion factor. I'm going to do 3.28 feet are in 1 meter because I want my answer to be in feet and I want meters to cancel out. So I put the 14 meters over 1 and I multiply by my conversion factor, 3.28 feet over 1 meter. The meters in the numerator and the denominator cancel out. When I multiply across, I'm left with feet. And what I get is 45.92 feet. Okay, so now for D, here's what I want you to think about. When you look at all of these measurements, when you see equals, it's an exact measurement. And when you see the approximate symbol, then it's approximate. So literally, see how on this one, I used this as my conversion, and it's an exact number. So that's why my answer was an exact number. And then when I used, erase that, remove that, when I used this, 1 meter equals 3.28 feet. Ooh, this was an approximate. I should have, for this answer, put in the approximate symbol. It's approximately 45.92. And so you can see that what I'm doing is I'm always using the equal sign when my conversion is exact. And if it's not exact, then I use approximate. Use equal when conversion factor is exact. And then I use the approximately when the conversion is just an approximation, which means it's been rounded. Okay, so now let's get to the lesson. It's not that much different than what you've been doing. We are going to be changing units. So here's the idea. You have this picture that says that your heart pumps 5 quarts of blood per minute. So I do this. I write 5 quarts per minute, right? And then I look at, that's the information I was given, and I look at the question, and the question says how many liters, right, does the human heart pump per minute? So notice it's still per minute, but instead of knowing quarts, I want to know liters, because let's say you're talking to somebody from Europe, Canada, almost the rest of the world uses metrics, so they might like the answer in quarts because then they can picture it, right? And we're better with quarts because we're picturing, you know, you go to the store and you buy a quart of milk. You don't necessarily buy liters of milk. Okay, so here's what I want to do. I want to get my conversion factor. Oh, and I want to do this. I want to say it's going to be approximately how many liters per minute. So I have my unit set up already in my answer so that I make sure that I grab the right conversion factor. So here's my conversion factor. I look on the list of, let's see, when I'm taking the customary and turning it to metric, this is the list that I'm going to use. And I see that the conversion factor is the quart and the liter right here. So every 1 quart is equal to 0.95 liters, or 0.95 liters equals 1 quart, right? You don't do anything fancy with the conversion. You just figure out which one needs to be on top. Literally, the second option that I write down is always just the reverse order. Okay, so now I'm going to move this, and what I need to do the math, I'm going to take 5 quarts per minute, and I'm going to multiply it by the conversion factor that has liters on top, and I want the quarts on the bottom to cancel out. So I get 0.95 liters for every 1 quart. The quarts in the numerator and denominator cancel out. When I multiply across and multiply across, I end up with liters over minutes, and then I do the math with the numbers. I do 5 times 0.95, and I get, remember I already have my approximate symbol. This is, I don't know why I put the liters like that. It's approximately 4.75 liters per minute. Okay, let's look at an OYO. You're going to be writing down a rate and then you're going to be converting it. So I'm going to first underline the rate, 300 gallons per minute. And then notice that this is not customary to metric, because now the question is asked, what is this rate in gallons per second? So we're literally looking at right now, the units are minutes, and I want to know how much it leaks per 1 second, right? Because I want to visualize what's happening in 1 moment of time instead of 1 minute. Okay. So, pause the video, think about what you would do for a conversion factor. And I'm going to start by writing the rate, 300 gallons per minute. And I want to know that it's equal to some blank number of gallons per second. All right, so obviously the conversion factor that I need is minutes to seconds. So I know that there is, for every 1 minute, it equals 60 seconds. And if I flip it around, 60 seconds is 1 minute. So I'm going to write my math here, 300 gallons per 1 minute. I need to put minutes in the top, and I want seconds on the bottom. So I'm choosing this as my conversion factor because I want the minutes to cancel out. 1 minute equals 60 seconds. The minutes and the minutes cancel out. That leaves me with gallons on the top and seconds on the bottom. Awesome. And then when I do the numbers, right, when I multiply across, I can ignore the units for now because I already know the units are going to be correct. I get 300 over 60. 60 goes into 300 5 times. Remember, you can also simplify before you multiply. I could have done this. I probably would divide by 10 and divide by 10, numerator, denominator. That gets rid of zeros. That leaves me with 30 over 6. And now I could start simplifying by divide both by 6. And I would still end up with 5. Or at this point, I could multiply across. And I get 30 divided by 6, which again is 5. So I'm going to go ahead and put it's 5 gallons per second. So it makes sense if you have a measurement in minutes, that's a big number, right? 300 gallons per minute is a lot. It makes sense that it's only 5 gallons per second because seconds are smaller units. So you would expect proportionally that this number would be smaller. Now, if I do in the opposite direction, if I converted from seconds to gallons, if somebody said, hey, this tanker is leaking 5 gallons per 1 second, it makes sense that per minute there's 300 because seconds are smaller units and there's more seconds inside of a minute. Okay. All right, let's look at another example. This time we're converting both units. So here's that picture of a zip line, so fun. Your speed is, 15 miles per hour. And it says, what's your speed in feet per second? So now I want you to notice that both units on the top and the bottom are changing. So we're going to set up something like this. This is my first piece of information. 15 miles per 1 hour, right? So there's my 15 over H. It's going to be equal to a certain number of feet per second. So you're seeing that the miles has to change to feet and the hours has to change to seconds. Okay, so So the first conversion factor that I'm going to grab, and it's not, okay, so just so you know, right, so this is US customary to metric, this is metric to US customary. Both miles and feet are customary. So here's what you need to know. You need to know how many feet are in a mile. And it's 5280 feet are in 1 mile. Or I flip it around, right? And then I do 1 mile for 5280 feet. Now, when I go from, okay, so that's going to be the, and I'm going to set up this kind of a long chain of multiplication so that you can see that you can basically do it, all the converting at once. Okay, so I'm going to choose the conversion factor that has feet on the top because I want the miles to cancel out. Okay, so now I'm looking to convert hours to seconds. So one way I could do this is to first think about two conversions like this. So every 1 hour is 60 minutes. And then I'm thinking about this. Every 1 minute is 60 seconds. So right there, I'm actually converting right now the hours to seconds. So when I multiply minutes and minutes, the numerator denominator cancel out. That leaves me with a new conversion, which you might have already been able to figure out, that in every 1 hour, E equals 60 times 60 is 3,600 seconds. So 1 hour is every 3,600 seconds. And then I need to figure out, should I reverse the order and do 3,600 seconds per every 1 hour? Well, I want the seconds to be on the bottom. So this is the conversion factor that I want for that. So now I have two conversion factors. It's going to be super cool. Okay, zip line, whee, you're going away. So I'm going to start with my original number, 15 miles per hour. And I'm going to multiply by this conversion factor, which is 5280 feet per 1 mile. And then I'm going to multiply by my second conversion factor, which is 1 hour is equal to 3,600 seconds. So watch what happens. The miles cancel out, numerator, denominator. The hours cancel out, numerator, denominator. When I multiply across, I just want you to see I get feet over seconds. And now I'm going to look at the numbers that I have 15 times, right? So I get 15 times 5280. On the bottom, this is 1 times 3,600. You don't have to show that step necessarily, but that's what I got. And then when you multiply across and then you do the division, you end up with 22 feet per second. So the middle step here was 79200 divided by 3,600, and you end up with 22 feet per second. Pretty fast, right? It's easy to picture going 22 feet per second, or a little bit easier. Okay, last OYO. You have the information that a tennis ball travels at 120 miles per hour. What is that rate in feet per second? So I set it up, 120 miles per hour, and I want to know how many feet per second it equals. I'm just going to point out that the conversion factors between the feet and the miles are already here, right? So you've got those. And so go ahead and pause the video and try this one on your own. See how many feet per second it equals. So I'm going to set up 120 miles per hour, and I'm going to multiply by 5280 feet in a mile so that the miles will cancel out. And then times 1 hour is equal to 3,600 seconds. And then miles cancel, hours cancel, when I multiply, I don't even want to try to do simplify before I multiply with this many numbers. It's just easier to multiply across. So I end up with 633,600 feet end up being on top, and then on the bottom I have 3,600 seconds, and that simplifies to 176 feet per second. And that is really fast, right? If a tennis ball is going 120 miles per hour. Okay, good luck with the homework. All right, I did want to just point out that this is what the problems look like. Like I said, they're on a worksheet, but notice that for some of them, you're just converting one unit. Notice you're going from kilometers to miles. This would be metric to customary. If you go from the liter stays the same. If you go from minutes to hours, it's customary to customary. Just notice what units are changing, and that's the units that you need to look for the conversion factor. Okay, good luck.